mechanical side. Our vehicles use currently the heat pump-based technology for the thermal system. But before heat pump, our vehicles used to have a dispersed thermal system connected by hoses. Engineering was inspired from circuit boards and then created a system which was extremely integrated, where 60% of the system was the size of a basketball, where it contained about 100 components, 50 sealing interfaces, and several different manufacturing processes, all were packaged into this tight size. Now, why are we talking about this? Well, we launched this system right during the outbreak of the pandemic in Model Y. The team was forced to manage 100+ components from different suppliers around the world remotely. So there are 4 videos playing at the same time. One is the video of the manual line that was created when we started the production. And this manual line produced a lot of quality issues, let alone throughput. So we quickly pivoted to a semi-automated line. But in spite of that, although the throughput was great, the quality issues sustained. So our team decided that fully automated is the only way to go. So before we automate the line, we created a 3D simulation. Now, not many companies or teams have this capability, where at this point, now when a part gets spec'd, we have the ability to create a 3D simulation of all the complex sub-assemblies that would be involved in making the part, and tell the suppliers exactly what equipment to purchase, what to test, and create an end-to-end line in simulation. And that's what we did here. So with the help of the simulation, we had a very detailed sub-assembly cell, which was juxtaposed with the supplier's factory layout. And then we, after a back and forth of iteration and optimizing the processes, we implemented this fully automated line in less than 8 months. And the results were remarkable. 99% reduction in labor force. So a line that would need 1,000 associates to build the super manifold in full volume now just takes 10 associates. And the quality also went up by an order of magnitude. We have a defect rate of less than 0.005%, and a super manifold rolls out every 7 seconds because we have created many automated lines. And these factories are the size of 2 football fields, by the way.
Roshan had to one-up me on that one. 99%, 2 football fields.
So why are we talking about this? In a world where labor costs are increasing, labor participation is decreasing, there is a huge turnover, and the cost of implementing automation is going down by 3x in the next 10 years. This is how we are thinking about complex assemblies, and we are going to push this type of thinking into our supply base more and more, who will be building our complex assemblies. This is the only way we think we can confidently scale to the 20 million vehicles target. To summarize, we have laid the foundation in getting ready to execute Master Plan 3. Our strategy is supply chain design simplification. We are going to make sure that we have more control into the tiers of the supply chain. We are going to grow responsibly and sustainably with our long-term partners, and we'll automate.
Yeah, it's like, going from 0 to 40,000 cars a week was tough. I mean, it took a lot of trial and error. It took a lot of learning. There was a lot of pain. There's a lot of mental scar tissue, as Elon calls it, through that process. But now that we're at that level and the foundation is set, going from 40 to 400 is not gonna. It doesn't really faze us. We have a capable team. We've got capable external partners that have gone through hell with us. Our leadership team is galvanized behind the mission, and we're gonna get it done. So I'd like to thank you for your time and hand it off to Drew and Tom for the next presentation. Thank you.